First of all, trigonometry and the trig functions that we're doing here always deal with right triangles. And they always deal with the relationships or the ratios of the sides. Ratio of sides. Okay, and when we had, if you look at a right triangle like this, let's say this is angle A, angle B, angle C, okay, you have to, the first part about this is you must understand which ones are the sides opposites, which ones are the sides adjacent, and which ones are the hypotenuse. The hypotenuse should be the easy one for you because it doesn't change. This is the hypotenuse, always. Always. It doesn't change. It's the one that's opposite the right angle. It's always going to be the longest side, hypotenuse. Now the other two change based on what angle you're looking at. Okay, if I'm talking about angle A, okay, for angle A, the side opposite, the side opposite is just what it says. Here's your angle A. If you draw an arrow that goes all the way to the opposite side, the side opposite would be side CB. For angle A, the side adjacent is going to be the one that makes up the angle that's not the hypotenuse. So that is side BA. Okay. If you're talking about angle C, okay, for angle C, the hypotenuse still stays the same. It's still that one. Okay. The adjacent side for angle C is going to be CB. And the opposite side is going to be, if you start at C and go opposite, it's going to be side BA. Those are the most, that is the critical part of actually doing this. The rest of it actually is pretty easy.
So the opposite of angle B would be angle.
Well, the opposite, we don't ever do angle B really because it's the hypotenuse, and you don't have, it doesn't work with that. You never really think about the right angle, it's always the other two angles. Because we're actually going to be able to figure out what these other two are. We know this is a 90-degree angle. We don't know what these are, but we can figure out what those angles are based on what we're going to do today. Now, the three main trig functions here, there's, well, I believe there's 6 of them. They're the opposites of these. You have sine, spelled like this, cosine, and what we call tangent. They probably appear on the maps test. If you got up to that level, consider yourself fortunate. And the way to remember these relationships is by remembering this little Native American chant here. So, ka, toa. I'll tell you what they are in a second. Write it down. So, ka, toa. Thank you, Kyle.
Thank you for that.
And what that's just like a little mnemonic device to get you to remember what relationship you're talking about. When you talk about sine, sine equals the opposite over the hypotenuse. Cosine equals the adjacent over the hypotenuse. And tangent equals the opposite over adjacent. And this whole SOHCAHTOA thing is just an easy way for you to remember what those relationships are. Okay? So, SOHCAHTOA. If I would have a right triangle that looks like this, here's my right triangle. Again, let's make this angle A, angle B, and angle C. Okay? And I don't give you any numbers here so we don't know anything yet, but if I were asking you to give me the sine of angle A, the sine of angle A is the side opposite of angle A over the hypotenuse. So The side opposite of angle A is side BC over the hypotenuse, which is side BA. That is the relationship that you would be looking for.
Then you have to solve it.
But I haven't given you the numbers yet. Once you get the numbers yet, you will be able to figure that out. Now, realistically, again, you should probably have some calculators to do this, but we're gonna go old school for just a little bit. And old school means, back when I was a kid, we had the trigonometric table. Nice and big.
Oh my gosh, that's a lot.
Oh, it's like
Through the papers.
This is the reference sheet that you'll look at.
So many examples.
You look pretty smart when you do this. Gabby, I can only tell you, if you know this, you'll get into a better college and quite possibly have a higher paying job.
higher IQ. So then you can play more video games and buy better ones. Exactly. And I have more money to spend. Yeah, I wanna go. Then you can buy SpongeBob. SpongeBob season 17.
Sure.
Don't be intimidated by looking simple. Anything dancing, engineering, that stuff. Okay, here you go. Take a look at problem number one on the thing, and again, we haven't talked about how to do this, but I want you to be able to see what we're going to do here. Problem number one says you're supposed to find the trigonomic ratio. So you've got the triangle here, and I will. Here's your triangle. It was what? 30, 40, 50 ABC. 30, 40, 50. A right here. B right here, C right here, right?
Yeah.
Okay. So they tell you, they want you to find the ratio of cosine of what angle?
A.
Cosine angle A. Okay. So right away you say, okay, cosine, so TOA, cosine equals the adjacent side over the hypotenuse. So you find angle A, which is right here. The adjacent side is the one that's not opposite and not the hypotenuse. So the adjacent side is 30. Are you with me? There's angle A. The one that's next to it that forms the angle that's not the hypotenuse is that. The hypotenuse is always the longest side. So the hypotenuse is 50. So the ratio is right here, except we usually do sine, cosine stuff in decimal form. So you reduce it. 3/5 is what as a decimal? 0.6. 0.6.
How does that have to be in decimals?
3/5 is 0.6 in the decimal. If you divide 5 into 3, you get 0.6. You can't change that.
Oh, I see.
Now, what that helps you in doing, and where your little table comes into play on that, and they didn't ask you for this, okay? If you look at your little table, you will be able to figure out what the actual angle for angle A is, because if you look under cosine, see the column that says cosine?
Yeah.
If you scroll down cosine and find where you find a 0.6, whatever degree angle that says that corresponds to 0.6, if you go down there, it looks like it is, or close enough to it.
37
Yeah.
or 44.
No, it'd be 53 degrees.
53, yeah.
If you look, find the column marked cosine, find where you see something closest to 0.6 in under that column, and that'll tell you the degree angle that you have there. 0.6 under cosine
So the degrees is 53.
0.6 under cosine is 53 degrees. That means that angle A would have to be 53 degrees. 53 degrees. They didn't ask you for that, but I thought because it does ask you. On the back side, you'll be asked for some of that somewhere. Get it?
So why does that have to be in decimals? Why didn't Julie have fractions?
Because there are no fractions on your table. Look at problem number, well, you know what, flip the paper. Let's look at problem number 11.
Hey.
25, 29, question mark. Okay, if you're trying to find the angle in question here, okay, you have to look at this triangle, look at what you're given with respect to what this angle is here. And it doesn't matter whether you call it angle A, angle B, whatever it is. But what do you know? I suppose with this angle you should probably label the sides. This side is what with that angle? That is side opposite. This side is the hypotenuse side, correct? And this side would be the adjacent side. So the two sides that you are given are the adjacent and the hypotenuse sides. So you have to think of the trig function that uses adjacent and hypotenuse. Which? Sine, cosine, or tangent? Ca. Cosine equals the adjacent over the hypotenuse. That's the only one that you know. You don't know the opposite, so you can't use any of the ones that have opposites in it. Okay? So then you just write that down. You know that the cosine of whatever question mark angle is, what is the adjacent side?
25.
25. What is the hypotenuse side?
29.
29. And now, unfortunately, children, like I said, it'd be nice if you had a calculator, but this won't be too bad. If you do 29 into 25 and get the decimal, you'll be able to look up on your chart what degree angle that is. This is pretty close to 30, so I'm going to guess this is a 0.8. What's that? 72, 16, 23. You end up with 180. That's close to 30 again, so I'd say it's 0.86. You probably can stop after that and then look on your table. Under cosine 0.86, how many degrees?
30, 31.
Well, and again, this is an approximation.
31.
Is it 31?
31. Yeah, it's 31. I think 31.
30. What are we doing? 0.86. Yeah, it'd be 30. Why did you say 31? Well, I don't know, but I didn't go the next one out. If you want me to go the next one out, 6 times that is what? What is 180 minus 29? 151. That's right. 54. 5. 12. 174. That didn't really work out, did it? Oh, so this ends up being like 0.865. Which one is it closer to now?
Still 30.
Okay, so 30 degrees. That would be the 30 degrees that this angle would be. And because of that, you know that this is actually probably going to be 60 degrees because we have to add up.
30, 69.
So it's what?
This is 30 degrees. See if by some chance you couldn't figure out problem number 12.
36.
Just try. I'll walk you through it in a minute, but I want you to try.
Yeah,
I know it's 36.
21. 21:10. And if I were Zach, I would probably start by labeling the adjacent, opposite, and hypotenuse angles with respect to where the question mark is. That's important. You can't just label anything. You look at the question mark. The side opposite is right here. The side adjacent is right here, and the hypotenuse is right there. So, the two numbers you're given are deal with both the hypotenuse and the opposite, so you have to use the trig function. Which of those three has opposite and hypotenuse in it? Sine. So, sine SOHCAHTOA is opposite over hypotenuse. So you make that ratio, the opposite is 10 over the hypotenuse of 21. You just need to figure out what that is as a decimal, and then you can use your chart to figure out what that angle is. It's a little complex, but certainly not above or below the complex.
If I get this right, I'm so smart. I should just use my sister's trigonometry calculator.
You should.
Oh, is that what they make those things for?
Is this 4?
4. I think she's sold. I think it's 25. It's 28. I think it's 25.
7?
I got 40.
Did I do the division wrong?
Yeah.
That's what I got. That's what I got.
That's what I got. That's what I got.
Oh, so you find sine, the column that has sine in it, find 0.47 or something that's as close to that as you can get. Was it 30?
28 degrees. 28 degrees.
I got 65 degrees on.
Sine and 0.47 would be, I'd use the 28 degrees.
Yes. Let's go.
Go ahead and do the next one.